So question number 9 of our exercise problem in the unit number 1, electrostatics. So let us see the question first. The question is, a spark plug in a bike or car is used to ignite the air fuel mixture in the engine. It consists of two electrodes separated by a gap of around 0.6 millimeter. To create the spark of an electric field of magnitude 3 into 10 to the power 6 volt per meter is required. What potential difference must be applied to produce the spark? If the gap is increased, does the potential difference increase, decrease or remain same? Find the potential difference if the gap is 1 millimeter. So what is that they have given us? A spark plug which is having two electrodes, and these two electrodes are separated by a distance. Initially it is 0.6 millimeter. It is the distance between the electrodes, and they have given the electric field between these electrodes. So it is electric field value E is given, which is 3 into 10 to the power 6 volt per meter. So what is the first question they are asking us to find is, what is the potential difference that must be applied to produce the spark? We have to find the V value, potential difference V value, V between the electrodes A and B. So we'll just first discuss with the first question. So you have E value, D value, you have to find V. So the equation relating all these three terms is V is equal to E into D. So it is direct simple substitution. E value is 3 into 10 to the power 6 and D value is 0.6. It is in millimeter, so you convert this into meters. 0.6 into 10 to the power minus 3 meters. 0.6 into 10 to the power minus 3. So when you multiply this, it is 18 into 10 to the power. So it is 1.8 into 10 to the power 3 when you add up the powers here. So it is simply 18 into 10 to the power 2, that is 1800 volts. So this is your voltage, this is your potential difference between the electrodes for this case. That is your first case, first problem, first part of the problem. What potential difference must be applied to produce the spark? So this much potential must be applied. So in the second case, they have asked, if the distance is increased, what will happen for this potential difference? Will it be increasing or decreasing or remain same? Is what is the second part of the question, B part. So as we know, the potential difference formula V is equal to E into D. You can see that the potential difference and the distance are directly proportional. So when the distance value increased, this V value will also be increasing. So my potential difference will increase. So you have to write this formula and write it as V is directly proportional to D. So the potential difference will increase. So this is the second case. And in the third case, they have given, in the first case they have given the distance as 0.6 millimeter, and now they've increased the distance for the third case as distance is equal to 1 millimeter. So convert this into meter, it is 1 into 10 to the power minus 3 meter. For this case, you have to find the potential difference VAB value, which is E into D, and the E value is as such same. So it is 3 into 10 to the power 6 into this distance value is 1 into 10 to the power minus 3 meter. So when you multiply this, add up the powers here. 3 into 1 simply 3 into 10 to the power 3. That is 3000 volts. This is for your third case.